Okay, in this chapter we're going to talk about radicals and something that's closely related to radicals, which are rational exponents. So I want to start you out with some radical basics and a few properties of radicals. So the first thing I want to talk about here is, let's talk about rational exponents first. A rational exponent includes exponents that can be written as fractions. So here are some examples of rational exponents. X to the 1/5 is a rational exponent. Negative 64 raised to the 1/3 power, 1/3 is a rational exponent. 27 to the 2/3, 2/3 is a rational exponent. 4 to the negative 3/2 is a rational exponent, and so forth. Now, all integers are also rational numbers. So technically, 2 to the 3rd power, 3 is a rational number. 3 to the negative 5 is a rational number. But most of the time when we're talking about rational exponents, we're really focusing on exponents like negative 3/2 or 2/3. All right, so to understand rational exponents, I want to give you this property here. If you have x to the 1/n power, that means the nth root of x. So an example would be like if I have 8 raised to the 1/3 power, that's the same as the cube root of x. Or if I have negative 32 raised to the 1/5 power, that would be the 5th root of negative 32. Or if I have 100 raised to the 1/2 power, that would be the same as the square root of 100. Okay? And anytime the nth root of x is equal to y, then that means that y to the n equals x. So for instance, if the cube root of 64 equals 4, it's because 4 cubed is equal to 64. Now let me give you another property, property 2 here. Let's say you have x raised to the m/n power. Well, that means that's the same as saying the nth root of x to the m. Or you could do it another way. You could say it's the nth root of x, and then all of that is raised to the m. So it can be expressed two ways, but usually when you're simplifying these, there's usually a better way. To do it. In other words, one of these is usually a better way to go when you're simplifying these. So like for instance here, 8 to the 2/3, I could write that as the cube root of 8 squared, or I could write that as the cube root of 8 quantity squared. Now if I was simplifying this, I would probably prefer to write it like this, because the cube root of 8 is easier to get than the cube root of 64. But the cube root of 8 would be 2, and 2 squared is 4. And so, you know, that would be easier. But we'll get to that later. And then if you have negative 32 raised to the 3/5, that would be the 5th root of negative 32 raised to the, I'm sorry, that should be a 2 right there, 2/5. So let me correct that real quick. Okay, start over, do-overs here. Negative 32 to the 2/5 would be the 5th root of negative 32 quantity squared, or the 5th root of negative 32, and have the entire radical squared. And then one more, 100 to the 5/2 power would be the square root of 100 to the 5th, or the square root of 100 to the 5th power. Now, what you might notice here is when we do these rational exponents, the denominator of the exponent actually represents the root, and the numerator of the exponent represents the power. Okay, so now let's apply some of these properties. We know that 8 to the 1/3 power is the same as cube root of 8. And since 2 cubed equals 8, the answer would be 2. Now, we know that negative 32 to the 1/5 power is equal to the 5th root of negative 32. And the 5th root of negative 32 is actually negative 2. So that should equal negative 2. The reason is because if you raise negative 2 to the 5th power, you will actually get negative 32. Okay? So I'm not sure why I didn't have the negative there, because I did it over here on the 4th example. But anyway, all right, now 8 to the 2/3 would be the same as the cube root of 8 quantity squared. Well, the cube root of 8 is 2, and 2 squared is 4. And then if we wanted to do negative 32 to the 3/5, again, that should be 2/5. All right, so it's negative 32 to the 2/5 is equal to the 5th root of negative 32 quantity squared. And the 5th root of negative 32 is negative 2 quantity squared, and negative 2 quantity squared is 4. Okay, so just a couple of typos there that I need to clean up, I guess, on the original document. All right, let's talk about negative exponents. If you have x to the negative n, that actually can be written as 1 over x to the positive n. So for instance, if you had 5 raised to the negative 3rd power, that would be the same as 1 over 5 to the positive 3rd power. And then you could cube the 5 and get 125. Or if you had negative 3 raised to the negative 4 power, that would be 1 over negative 3 raised to the positive 4 power. And then when you raise negative 3 to the 4th power, you would get 81. So that would be 1 over 81. Another property is if you have 1 over x to a negative power, you can actually write that as x to a positive power. So if I had 1 over 4 to the negative 3, I could write that as 4 to the positive 3, which is just 4 cubed, and 4 times 4 times 4 is 64. Okay, let's look at a couple examples where you have negative rational exponents. So if I have 25 to the negative 3 halves, based on this property up here, that's the same as 1 over 25 to the positive 3 halves. So what does the 25 to the positive 3 halves mean? It means the square root of 25, and that quantity is cubed. So that would be 1 over, the square root of 25 is 5, so you'd have 1 over 5 cubed, which is 1 over 125. Okay? Okay, here's another one. Negative 64 to the negative 2/3. Well, that would be 1 over negative 64 to the positive 2/3. So notice the exponent changes to positive when I write it like this. Now, not the base. The negative 64 still stays negative. All right, so what is negative 64 to the 2/3? It's the cube root of negative 64 quantity squared. Well, the cube root of negative 64 is actually negative 4. So that would be negative 4 quantity squared in the denominator. So you'd have 1 over negative 4 quantity squared, which is 1 over 16. Okay, let me show you another. There's a special property I like to share with students for fractions. And this has to do with the negative exponent. If you have a fraction of a over b to the negative n, you can flip the a over b over and write this as b over a to the positive n. Okay? Because really what the negative does is gives you a reciprocal. So for instance, if I had 3 over 2 raised to the negative 4, that would be the same as 2 over 3 raised to the positive 4. And of course, if you multiply 2/3 together 4 times, you can do that on scratch paper. 2/3 times 2/3 times 2/3 times 2/3, you get 16 over 81. Now, negative 8 over 27 to the negative 2/3, using this property, would be negative 27 over 8 to the positive 2/3. So now let's think about what that means. So when you raise something to the 2/3 power, it means you take the cube root of it and then you square it. So if we take the cube root of negative 27 over 8, well, the cube root of negative 27 is negative 3. The cube root of 8 is 2. So we get negative 3 over 2 quantity squared. And then when you multiply negative 3 halves times negative 3 halves, you get positive 9/4. Okay? Now, you might want to review your exponent properties from previous algebra courses, but remember x to the m times x to the n is x to the m plus n. X to the m divided by x to the n is x to the m minus n. X to the m raised to the n is equal to x to the mn power. Xy to the m is the same as x to the m y to the m. X over y to the m is x to the m over y to the m. And always remember, anything raised to the 0 power is 1 as long as the base isn't 0. Okay, so here, what I did here is I just listed some perfect squares for you to kind of give you a reminder. All of these numbers here that I listed are perfect squares. Like 0 is a perfect square because the square root of 0 is 0. 1 is a perfect square because the square root of 1 is 1. 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3. 16 is a perfect square because the square root of 16 is 4, and so on. And then if you get over here further, square root of 324, 324 is a perfect square because it's the same as 18 squared. So square root of 324 is 18. Square root of 361 is 19. Square root of 400 is 20, and so forth. Now, remember that the square root of a negative number is not a real number. So if I ask you for the square root of negative 100, that's not a real number. Now, after we talk about complex numbers, we can actually simplify this, but for now, we don't have the tools to simplify it. All right, let's talk about perfect cubes. Here are some perfect cubes: 0, 1, 8, 27, 64, 125. They're perfect cubes. 0 is a perfect cube because 0 cubed is 0. 1 is a perfect cube because the cube root of 1 is 1, because 1 cubed equals 1. 8 is a perfect cube because the cube root of 8 is 2, since 2 cubed equals 8. 27 is a perfect cube because the cube root of 27 is 3, since 3 cubed is 27. And 4 cubed is 64, so 64 is a perfect cube. 5 cubed is 125, so 125 is a perfect cube, and so forth. Now, you can take the cube root of a negative number. The cube root of a negative number is a real number. So if I wanted to take the cube root of negative 64, I could. It's just going to be negative 4, because negative 4 times negative 4 times negative 4 is negative 64. So here are some other common roots that you might run across. The cube root of 1,000 is 10, because 10 times 10 times 10 is 1,000. The cube root of negative 1,000 is negative 10, because negative 10 times negative 10 times negative 10 is negative 1,000. The fourth root of 16 is 2, because 2 to the fourth power is 16. The fourth root of 81 is 3, because 3 to the fourth power is 81. The fifth root of 32 is 2, because 2 to the fifth power is 32. And the fifth root of negative 32 is negative 2, because the fifth root of negative 32 is negative 2. Now, I know I haven't talked about certain roots, because other roots you can't give the exact value. Like if I wanted the square root of, say, 7, there's no exact number that I can square to get 7. Or if I wanted the cube root of, say, 4, then there's no number that will exactly give me the cube root that will give me 4 if I cube it. But we'll deal with those later. But right now I'm just worried about numbers that work out perfectly for you. So perfect roots, in other words. All right. Okay, so that this should be good enough for the introduction section on rational exponents. And the next video I'll go ahead and start talking a little bit more about radicals.